going to discuss inverse matrices. So what an inverse matrix is a matrix when you multiply it by another, gives you this beast called the identity matrix. The identity matrix is always easy to identify because along this diagonal you get ones, and along the other diagonal you get zeros. It's that simple. So let's go ahead and figure out if the two matrices that are given you here are indeed inverses of one another. So take a look up here, this line right here. It says if I multiply two matrices in either order and I get this thing called the identity matrix, then they are indeed inverses. So let's give this a shot. I'm going to do A times B. So 3, 2, 4, 3 times 3, -2, and -4, +3. So we multiply them together. Remember, row times column. So 3 times 3 plus 2 times -4. First row times first column. And then 3 times -2. The next. Don't add it. That's my next term. So first row, second column. So I multiply by the first row and second column. Think about it. It really makes sense. So first row, 3 times -2, and then 2 times the 3. Then I look at my second row and my first column. So 4 times 3 plus 3 times -4, and then 4 times -2, and then 3 times 3. Go and do the arithmetic. 3 times 3 is 9. 2 times -4 is 1. Multiply them and add them, get 1. These will give you opposites because -6 plus +6 is 0. On the bottom, I got a +12 and a -12, so that's negative, oopsies. That's not negative anything. That's plain old, ordinary, favorite number, whole world, 0. 4 times -2 is 8 plus 9 is 1. So these two are indeed inverses of one another. Okay, moving on. So, how do you actually find an inverse of a matrix? We're going to use something called the determinant method. So the determinant is a little bit of arithmetic. It's done pretty simply. So a little multiplication, some subtraction. So I'm going to color code here. I'm going to make my 3 and my 2 red. I'll multiply them together. I'm going to make my 1 and my 5 green. I'm going to multiply them together. And then subtract. So take a look. 3 times 2 is 6. 1 times 5 is 5. So the determinant of this matrix would be 1. Now we're not going to use this to find the inverse of matrix A. You take the reciprocal of 1. So 1 over 1 is 1. So that makes it pretty easy. And then our next step is to take the two numbers, the 3 and the 2, and switch them. 2 goes here, 3 goes here. And take the 1 and the 5, we don't switch them, but we take their opposites. So opposite of 5 is -5, and then opposite of 1 is -1. And then we multiply it by the reciprocal of that determinant. Well, when we multiply anything through by 1, it doesn't change. So the inverse of our original 3, 5, 1, 2 is -2, I'm sorry, +2 -5 in the top row, and then -1 and 3. So if we multiply them together, we would get the identity matrix. 1's along that first diagonal, and 0's along the other one. Let's try it for one that's a little harder just because my determinant's not going to be 1. So determinant of matrix A. So we just abbreviate DET. First diagonal is 1 and 4. It's by 1 times 4. Second diagonal, 2 times 3. Multiply 2 times 3. So 4 minus 6, -2. We take the reciprocal of that. We're going to calculate the inverse. And inverse usually have a -1 as a superscript. So take that -2, excuse me, and flip it. So it's going to be -1/2. And then we need to do a little bit of manipulation to the numbers inside the matrices. Those two get switched. 4, 1. The other two, you just take the opposite. So I'm going to make that -2, -3. And then you do your scalar multiplication. So you multiply the -1/2 through. We'll get as our final answer. Oopsies, forgot to switch these. That's okay, we can fix that right now. I said we were going to switch them, but we didn't actually switch them, did we? So this is 4, and that's 1. So -1/2 of 4 is -2. -1/2 of -2 is 1. -1/2 of -3 is +3/2. You can write it 1.5 or 1.5, 1 5/10, whatever you want. -1/2 of a half is -1/2. So the top row are integers and the bottom are not. Again, if we multiply A times the inverse of A or inverse of A times A, you get this identity matrix of 1's along that first diagonal and 0's are along the other. You might have noticed something. It says use the determinant method to find if the inverse, to find it, and then there's that little caveat at the end, if it exists. So let's look at kind of a special case. Let's find the determinant of A. So -4 times 3 minus 2 times -6. Well, these are the same products. Whenever we get the same products and subtract, we get 0. Remember, the next step is to take 1 over that. And you all know that you cannot divide by 0. So in this particular case, you get a determinant that is equal to 0. Since we cannot take the reciprocal, the inverse of the matrix doesn't exist. Kind of a special case. So whenever you get the determinant equals 0, you're done. Question, how do I do this for a 3 by 3? That'll be in the next video.